Ready? Okay. Welcome everyone to my talk on how to modernize Eclipse RCP E4 applications tools. I'm Jonas. I'm working at Eclipse Source. We are a company supporting our customers developing tools and RCP applications. So we deal a lot with this topic. A little bit about the motivation I had when I submitted this talk. If you look at the EclipseCon program, a lot of talks are about new technologies like Che, like Thea, like everything in the web. And that's cool because we want to learn new things. However, if you look at the reality and if we look at our customer projects, they have existing applications based on Eclipse, which are sometimes 15 years old or even 20 years old, and they're still completely working, and they make a lot of business with that. And they not intend to just throw that away and re-implement everything from scratch. And one of the core strengths of the whole Eclipse ecosystem and the platform has always been that you can maintain it well. It had very little API changes over the years. It's a very stable program, platform. So what I would like to talk in this, or the topic of this talk, is how to modernize what you have there. And Eclipse is really used in a lot of areas, like a lot for tools, obviously, but also ERP systems and other systems, like in control centers and stuff. So it's typically used in areas where you have a maintenance cycle of more than 2 years and where you in turn do not have the budget to just re-implement everything from scratch every 3 years. So this is the topic for today. When I started to prepare this talk, I had some ideas in mind, but what I actually did is I talked to all consultants at Eclipse Source to collect stuff from different projects, and I also talked to consultants from other companies. And the question was like, what do you do with, do you have any best practices for modernization? Like how do you evolve Eclipse application? And actually the feedback I got was like huge. Like I could easily talk about this topic for a day with this content. I had to strip it down to the things which I would say are probably applicable to most of the project. If you're missing a question that is specific to your project, I'm very sure you're missing something. Please feel free to talk to me after the talk. Maybe I have some ideas about that too. But I'm sorry if I cannot cover like all specific modernization problems. The most recurring things I have observed in projects is the whole question around E4. It's still very omnipresent. You would be surprised how many projects are still on, for example, 3.6, because they're actually unsure how to migrate, when to migrate, if they should migrate. Then a huge topic is UI technologies. Like, is SWT still the right choice? How do we style it? Can we style it? Should we style it? What are alternatives? Then obviously I would like to quickly talk about Che and Thea, especially if, like, what does that mean if you have an existing RCP application? Can you change the target and recompile and you're done? And finally, this is a little bit of a generic part. I would like to present a basic architecture pattern that we have used a lot in project, and that is actually working very well. It might look familiar if you know the model view model model pattern. But I would like to map that on how you can easily apply that in Eclipse, and it has a lot of flexibility. And finally, I have a list of good and bad technologies. This list was originally a little bit longer because they're like personal preference from people. I've chosen the diplomatic way, so especially for the bad technologies. Okay, let's dive into the first question, Eclipse 4. So the questions typically are, do we need to migrate to Eclipse 4? When will the compat layer be deprecated, and are extension points deprecated? Just to answer 2 of those questions right away, there's no tendency, nor a bug report, nor anybody plans to deprecate the compat layer. And extension points are not deprecated too. They're just not used for views, handlers, commands anymore, but they're not deprecated. And there's no intention to do so. They're completely 2 rumors which are very persistent. Now, the first question, like, do we need to migrate to Eclipse 4? Let's quickly look at the options. So if we look at a classic 3.x application, besides a lot of other frameworks, it is typically based on 5 components, which is the Eclipse runtime, OSGI, stability JFace, and then we have the workbench in the middle. So the workbench, the plugin is org Eclipse UI, provides you with stuff like perspectives, handlers, editors, views. All those extension points are provided by this plugin. Now, when we switch to Eclipse 4, the only thing that actually changes is the API of this plugin in the middle, because instead of those extension points, it uses the application model, dependency injection, and services. All the other plugins basically stay the same. Of course, there are newer versions of those plugins too, but like not a radical change. So the only thing that actually changes if you switch to E4, like pure Eclipse 4, is this API. And now, when Eclipse 4 was developed, it would have been a huge effort to migrate all the existing tools, like for example the Java tools, to this new API, because they use the old API a lot. So what the platform team also provided is what we call the Compatibility Layer. That's a plugin org Eclipse UI.e4, which provides the exact same API as 3.x has provided before, but internally forwards that to the application model, dependency injection, and so on. So that means if you download any Eclipse version with a 4, starting with a 4, you have all the new concepts inside, but you can still use the old API. Now, what does that mean? There are actually now 2 options of programming applications based on Eclipse. One is this, using the compat layer, but on a new version, or this pure Eclipse 4, meaning using the new API. So why should you even care about this pure Eclipse 4 approach? So the advantages are you have this application model replacing those extension points for views, commands, and handlers. It's a little bit more efficient. Although keep in mind, if you have an existing application, maybe you evaluate how often you change the layout of the workbench. So if you add a new view once in a year, it will probably not pay off only for that advantage to migrate. You have generally a cleaner architecture because you can use dependency injection in POJOs. In turn, like your architecture will not be automatically clean if you switch. Like, I mean, it still depends on you what to do with that. Probably the most important point is you have more flexibility. You can more easily style tabs or anything of the parts of the workbench, and you can use JavaFX, or you can make your application a pure JavaFX application and get rid of stability completely. This is only possible with Eclipse 4, and I would say that's probably the most prominent reason to really migrate to pure Eclipse 4. The other ones are advantages, but you have to compare them with the costs. The disadvantage is you cannot, at least not in an official way, use 3.x plugins anymore, because if they use the old extension points and you remove the compat layer, they will just not work. So this is especially bad if you reuse a lot of stuff, for example, from JDT or CDT or stuff like that, because those plugins will not work then anymore. So that leads to actually a simple decision tree for the decision. So don't go for 3.x anymore. So do not stay on old versions. They are not maintained anymore. And if you don't book LTS and pay money for that, you will never get any updates. And sooner or later, you will run into a problem. And then you have to migrate with this problem, because of this problem, and you are under pressure. So we really recommend, like, the new platform is mature, it's stable, it's performant, that you migrate your tools to some 4.x version, some current version. What you actually can choose is either pure Eclipse 4, new API, or compat layer. And for that, to come to a decision, it's important to know that most existing tool components like JDT, CDT, Xtext, and all those frameworks, they still use the compat layer API. That means to come to a decision what's best for you is we recommend to look at all the plugins that you use, the third-party plugins, but also your own plugins. If you use a lot, or if a lot of them use the 3.x API, you might stay on the compat layer because it's just simpler, less effort. If you have only maybe one plugin using the 3.x API, in many cases, it's simple to refactor that a bit and get rid of the 3.x compat layer dependency then, because then you can go to pure Eclipse 4. And if you know 3.x base stuff or you start from scratch, then a recommendation would be to go to E4. You should look in the future a little bit, like if you get started from scratch and you know in half a year you want to include JDT, I would not go for pure Eclipse 4 because that would just make things harder for you. There is, even if you're on the compat layer, there are some patterns to develop in an Eclipse 4 friendly way, so you can actually grasp some benefits that you have in Eclipse 4 from an architecture point, also in Eclipse 3.x on the compat layer. I have an article in the references of this slide describing that more in detail. All right, let's talk about UI technologies. So SWT has been very successful in the Eclipse universe, and it really provides a lot of support for building tools. For example, the style text widget as a code editor, but also like a lot of stuff like EMF, you can generate a lot of UI, and there are other technologies like wizards. All this stuff is very powerful, and if you build a classic tool, SWT is still a great technology to do so. But the maintenance is slowly decreasing. I mean, it's kind of old. It's not that it's not maintained anymore, but for example, if you're in a niche system, like for example, if you're in Linux, the GTK support has been a little bit problematic in the last years. Now it's better, so they did a very great job of fixing that, but it's not like in the early days. There's just less developer on it. I wouldn't worry too much if you're on SWT, but at least it's something to watch. More important, the styling capabilities are still lacking, and they will probably never like match HTML or JavaFX. I don't think that's going to happen. And that means if you need styling capabilities for your application, then sooner or later you will either have to reduce your requirements or switch somehow. For many tools, this doesn't really play such a big role because it's not so important that they look nice, but for many tools, or it's actually a trend that tools also should be more usable and just look nicer. So if that's true in your project, you might hit the limitations of SWT. Now, what are alternatives? Two obvious choices, JavaFX and HTML5. Now, migrating to JavaFX. What would be the advantages? It's also Java, so you don't have to learn a new programming language. And if you know SWT, it's very, very efficient to train people in JavaFX. Actually, the API is more modern. Things are typically more simple, so the transition is very smooth. You have perfect styling. You can really do a pixel-perfect styling in JavaFX. And it's well supported in native Eclipse 4. So I've told you before, there is a renderer for Eclipse 4 written in JavaFX, so that's well supported. What's very interesting, you can embed JavaFX into SWT for a soft migration. That means you can, for example, take one view in your application and migrate that to JavaFX first, and then do the next, and then do the next, until you have re-implemented everything in JavaFX, and then switch completely. That works surprisingly well. I will show you a demo of that in a second. It's much better than, for example, embedding Swing into SWT if somebody has done that in the past. This works much smoother. And the disadvantages are you don't have really a path to the browser. So any web-based version of JavaFX I would consider to be dead. So if you ever want to go to the browser, this migration to JavaFX might be a dead end. And also, if you want to include web-based part, like if you also want to use HTML in your application, there's currently not a good browser widget for JavaFX for free. There is one, but it has some limitations, although there are commercial products covering this. But this, at least for free, the browser support in JavaFX is not perfect. In comparison, migrating to HTML. Advantages, perfect styling. I think that's obvious. It prepares a potential migration to the browser. So if you know that in 5 years you want to be in the browser completely, the efforts of transforming some UI to HTML are actually not lost, but you can reuse them later. And thereby it's kind of future-proof. Like the browser in HTML5 is kind of the UI technology today, so it's pretty likely that this is becoming the standard in the future. You can also embed as HTML into SWT, just like as described for JavaFX, and that also works quite well, although it is more difficult compared to JavaFX. And that's basically the technology boundary is just higher. Like, for example, handling selection or drag and drop between HTML and the Java process is just more tricky. While in JavaFX, there are some limitations too, but it's definitely smoother. Disadvantage is you have a technology mix, so you need people who can program JavaScript, HTML, CSS, and Java. And it's more likely that you have to refactor stuff because yeah, you need to provide some services that the browser can then communicate with. Those refactoring costs are not sunk if you ever want to migrate to the web though. Okay, so how does that look like, both options? So what you actually can do is in an application, you would have a classical SWT view. You can add in SWT a JavaFX canvas. That's an SWT component. And this allows to embed JavaFX components. So you will have then a view that is pure JavaFX code. And the same you can kind of do with the browser widget. And I will not go into technical details and just show you a demo that you get an impression. So let's start with JavaFX. This is the example application I had on Monday in my E4 tutorial. It's a very simple one. And as you can see, it just has a text field, but this looks like SWT because I haven't styled it yet. But it is actually JavaFX, and I can prove you that. And how do you prove that you are in JavaFX? With transitions. So here the absolute very reasonable feature is if I hover over here, this just turns, and the same over here. So this proves that this is actually a JavaFX embedded into SWT. So the frame is still SWT. And this works surprisingly well. So we have actually done that in several projects where we started with a pure SWT application. We step-by-step migrated the views to JavaFX, and then at the end, we removed the SWT frame and switched to pure JavaFX. This process is actually working surprisingly well. You have to be a little bit careful with the styling, like because for some period, you mix SWT with JavaFX. So in JavaFX, if the styling is like crazy, that your target style, you might the existing SWT parts and the new JavaFX parts might visually not fit together. So you need some strategy for that. Here we have an example. So that's a classic Eclipse IDE, and in the middle here, this is actually a browser widget showing a diagram rendered with a technology called GLSP, the Graphical Language Server Platform. So this is a browser. But as you can see, it's really responsive. I can move stuff around, so it doesn't feel like a web application. And again, styling is important. If you use a styling which fits the Eclipse look and feel, users will not even know that. So that's the other alternative. And to prove that, yay, I can zoom. Okay, now. Yeah, maybe conclusion on that, both options are valuable. JavaFX is closer to SWT from a technology point of view. HTML is more far away, but maybe more future-proof if you ever want to migrate to the web. Maybe even a mix of both is a good solution for your project. Okay, now I was already mentioning the potential migration to the web several times. So what does it mean, like migrating to Thea and Che? Scope of this talk is not to completely explain those projects, but just in a nutshell, Thea is a platform to build web-based tools. So Thea is kind of like Eclipse is for, or the classic Eclipse platform is for desktop. That's Thea for web-based platforms. It's a platform to create your own tools based on. Che is a workspace server. So if you move your development tools to the web, you need some way that, for example, a compilation process, if it runs on the server, it must run in somewhere, and the solution for that is containers. So every developer has his or her own workspace as a container on a server, and Che provides management around that, so that users can create their servers, that you can manage the resources, that you can share them with other people. So both frameworks in combination are a powerful solution to really build web-based tools. And there are additional technologies emerging at the moment, so it's really, there's a lot of speed in that area, so it's really a huge topic at the moment. For example, the graphical language server platform I've shown before, JSON forms, LSP with a combination with ISTEX, Sprotty, EMF Cloud, like the Eclipse modding framework for cloud-based applications. So a lot of stuff is coming up, but it is not like migrating to Eclipse 5. It's a complete technology shift. If you do it right, you hopefully are able to reuse a lot of your existing code when it comes to business logic or language logic or compilers or validation code or whatever. However, you very likely need to re-implement all your UI components because it's basically web-based, and if your existing UI components are based on SWT or JavaFX, they're not reusable. So that means you need to re-implement UI. You probably need to refactor your business logic to be reused. We believe that's in most projects that's worth it, especially if you're migrating, because then you avoid doubling the effort for maintenance. Now the question is, why should you ever migrate? You have a modern UI and styling. You have zero installation, which often plays a role. And you can basically enable new cloud-based business models, like you can provide a tool as a service. What we believe mainly is it is important to think about those topics right now, evaluate potential benefits you can get from there, and define a strategy and a time plan. Because if you know that you, let's say, want to start the migration in 1 year or so, that might already influence your architecture decisions today. Like, for example, do you choose JavaFX or HTML? How do you implement a new feature and all this stuff? And we had a talk about this particular topic on Monday. The slides with reference of that are already online, so that talk was named towards a strategy for a migration to the web, I think, or something. Okay, so now the last topic before the technology list, how to structure bundles, model or MVVM-like. This is basically describing a pattern which might look very familiar to you that we use in most projects, and that works really, really nice in practice. I just want to explain the pattern and while doing so, mention some benefits of it. Now the boxes that I will have on the slide are not necessarily bundles. Let's consider them to be packages for now. I will then afterwards talk about how to split that in bundles. And now, as an example, so consider any example feature that you implement in your tool. Let's say a button that you can press and then a table is filled with some results that are presented in the UI, for example. Now, what we typically do is we create a package called as the feature, myfeature.ui, which actually contains the real UI component. So this contains SWT code or JavaFX code, which really draws the UI. Now the first recommendation is whenever you start to implement UI, that you, while doing so, extract components that are potentially reusable, for example, a text field, or a dialog or anything basically into some central plugin. We typically call it core UI. Reason for that is even if you don't have a second user yet, is if there is ever a second user and the component is already in the core UI, they will likely reuse it. And you might like wonder why do we want to reuse a text field? If you ever change the default behavior of your text fields, you have one central place. And if you want to style all components in a similar way, you also have one central place. So I think that's very beneficial to extract those components as soon as possible. Also, the code in here will be much less. So this basically just calls some factories, okay, create text field, create dialog, and so on. Now, the next thing is we suggest to immediately create a second package called myFeature.viewModel and split. And that is, I cannot explain the full pattern today, but the basic idea is the UI bundle or the UI package only contains UI controls, but the state of the UI, meaning, for example, in this list example, the elements which are represented in the list are not part of the first package, but they are part of this view model, and they don't have a dependency to the UI technology. So that would mean in here, you could have a service called element service, and it has a method get elements, which is an observable list, for example. And now here you would create a table and bind that table against the get elements method of the view model. Now what you do by that is you actually extract the state and a lot of logic from your UI bundle, and you make this much smaller and easier to maintain. And this is actually not depending on any UI technology anymore. Now you wonder, like, where is this filled from? Like, where, for example, if I press a button, where does the data actually come from? Oh, sorry, forgot that. One core advantage is you can directly provide an implementation for those interfaces, for example, for the get elements, and fill it with mock data. That is very, very efficient if you create a UI. You don't have to connect it to any database or stuff. You can just provide some example data and program the UI against this example data, which immediately allows testing and reduces your development cycles. And I would really recommend to do this right at the start, not later, like we do a mock later. Like, use this for development rather than the real implementation. Now the real implementation, let's skip that for time reasons. The real implementation comes in like this. So we have what we call then my feature core. That is actually the business logic or the data model or whatever you need to fill your UI with entities. And this now actually connects, for example, to a database, to a file, or whatever. So that means the real implementation of this view model can then do a database call or a REST call or whatever to be filled with the real data. And now the nice thing about that is that you can, without having, for example, a database set up just by using the mock, as a replacement for this, you can fill your application with example data, or if you activate that, then you have the real data. And what works very well is, even if this is, so you can actually start with this whole part here and actually finalize the UI, and later on hand that over, for example, to some expert, like let's say some database expert, who knows then exactly, okay, those are the methods I need to implement with my business logic, and those are the methods how to fill the UI with data. And the UI is basically just bound to that. Now, what does this have to do with modernizing or migration? Like, besides, I'm very convinced that this is a good pattern for development, it has one additional advantage. If you apply that right, the amount of code in your UI depending layer, meaning code that is depending on SWT or JavaFX, will get smaller. So here we don't have a view model, and the green one is the view model, and this is how this could look like. This layer starts to grow, and it makes the red thing, which is the view, the UI depending code, smaller. And why is that important? If you want to switch to another UI technology, for example, from SWT to JavaFX or to the web, this is the thing that you throw away because you cannot just migrate it. But if this is super small, the view model, for example, you can very easily reuse. And this view model approach fits very good in web applications because you can can have this view model on the server and just transfer the state of the UI to the client and render it there. And many modern UI frameworks in the web work exactly like this. If you're familiar with React, this whole approach should sound very familiar to you. Let me check the time. Yeah. Yeah.
Would that mean that the state is held in the browser but on the server?
Yes, but
For like good pattern, well, one other option is to have the state at the client side so that the server stays.
yeah, it depends on the application. I mean, so those classical tools where you really have a workspace server already, then there will be definitely some state on the server too. And it depends on the size of the state. Like, I don't know, if you have a model that you cannot really load in memory, you cannot just transfer that to the client. So this is really depending on the concrete application. So one last comment about that. So if you think about how to separate those packages over bundles, like in an ideal world, you would create a bundle per package here. So for every of those 7 components, which will blow up your workspace a lot. Pragmatic solution, if you don't have alternative implementations of the view model or the core feature, you can bundle it like that. So that means the default implementation goes into the same bundle as the interface, and the same here. I mean, this way you cannot easily replace this from outside anymore, but if you have the code under control, that's typically not an issue. Okay, all right. Last slide, good and bad technologies. As mentioned, I had much more on the list, but there's a lot of personal preference. Like, I love this, I hate this. So I stripped this down a little bit to, I would say, objective recommendations. Buckminster, please don't. Who's still using Buckminster? Good. PDE Builder? Somebody say, yeah? I mean, you will not find people who can support you well. And 3.x versions as target or IDEs. Like, I've seen a lot of projects who force their developers to still use 3.x as an IDE, and I mean, this tool is like 12 years old, and it's really not nice for a developer to use such an old tool. So get rid of 3.x. Options are pure Eclipse 4 or compat layer. Good technologies, Tycho, still, I would say, the default, although BND tools are an alternative if you aim at like being closer to Maven and maybe also provide some parts of your tool in a pure Java way. Then BND tools are definitely an interesting alternative to look at. Although if you don't have a current problem that you cannot solve with Tycho, I would not say, okay, now you have to migrate from Tycho to BND tools. Those are 2 alternatives, both completely valuable, both fine. Oomph, in case you don't use it, a tool to automate your IDE setup. If you ever use the Eclipse installer, that's actually also Oomph, but you can customize that. You can actually automate a lot of stuff to onboard new developers more fastly. So you can actually, they press one button, an IDE is downloaded, all plugins are installed, the workspace is set up, the Git repository is checked out. So it's really, really worth the effort because you save a lot of time in setup. EMF, still a very cool technology, and it has its place in the cloud on the server. So we use it in EMF Cloud, in GLSP, in many projects, and it works well on the server. So it's still really, really powerful and useful technology. Declarative services. Who of you knows declarative services? Great. Like 2 years ago, I asked the same question. There were no hands up. This is really, really nice for communication of components in your application. And that would be it. Conclusion, I think I've mentioned everything. Just a quick hint. I will put the slides online. There are a lot of references in there. So about those topics, maybe some interesting reads for you. And besides that, are there any questions right now? Yeah.
Do you know about this other way around that you can render SWT tools on JavaFX? So this SWT on JavaFX, there's a project, I guess, but it seems like that.
Yeah. So we also quickly looked at the project. I have not seen anything running, and I find it a little bit difficult. Like how should that work well? Probably I mean, if it's really something you want to do, it's probably worth evaluating that path. But I think there's nothing out of the box that you can just use. No. All right. If you have any more questions, if you want to discuss a particular question specific for your project and want to get some opinions on that, please always feel free to talk to us and join us at our booth. We are there the whole day. Anything. And with that, I would like to thank you for attending my talk and enjoy the rest of the day. Thank you.